Guys, for all the solutions of this book, visit forthesakeofeducation.com. I've been working hard of putting all the problems into one convenient place for you to be able to do your homework easily. So pay us a visit.
Alright guys, let's do this video, last video for the day for me, which says locate the centroid Y bar of the beam cross-sectional area. So basically we're dividing this area into three parts. Oops, I have this on the eraser. This is the first part. This is the second part. And the last part is the part at the top. And then you know that each of these rectangles has a centroid at the very center of it. Perfect. Now all we need to do is build our table and find our centroid of our composite area, which is super easy. First, let's label each of the parts. So let's name this part 1. I'm going to name this part 2. And the one on the right, I'm going to name it part 3. Then notice that they're only asking for Y bar because X bar, it's obvious, since it is symmetric around this line right here. It's symmetric, therefore this is where the centroid X bar would be. I like to explain that even though the problem is not asking for it, that way you guys get a better idea of it and get used to seeing these things. So X bar is right at the center, and you know this is 400 millimeters, so you know that X bar is gonna be at 0.2 meters, because you know me, I like to convert millimeters to meters. So let me do that right here. 400 millimeters is 0.4 meters. 200 millimeters is 0.2 meters. And 50 millimeters is 0.05 meters. Not 0.5 meters, don't make that mistake. I see a lot of you guys are making that mistake a lot when you guys are asking me questions. So that being said, let's build our table. First thing in our table is our area, X curly, Y curly, and then X curly times the area, Y curly times the area. Then we have three parts, which are 1, 2, and 3, which we labeled them just a second ago. And this is our table. Now let's fill it up. Area of 1 is 50 millimeters times 200 millimeters, but I converted to meters, so that would be 0.01 meters square. The area of the second one is 400 millimeters times 50 millimeters. I converted it to meters and multiplied them together, and that would be 0.02 meters square. And the last one is the same as the first one, so it's 0.01 meters square. So now we got to do the location of the centroids. This first centroid right here is located at 0.025 and 0.1. This centroid is located at 0.2, 0.225, and this last centroid is located at 0.375 and 0.1. So now we're going to multiply the area by the points to get XA and YA. So the first one is 0.00025. Remember, this is in meters cube because this is a meter square and this is in meters. The Y is 0.001 meters cube. This one's 0.004 meters cube and 0.0045 meters cube, 0.00375 meters cube, and 0.001 meters cube. We're almost there. All you need to calculate is the sum of the areas. Sum of the areas right here is 0.04 meters square. sum of the areas at x is 0.008 meters cubed, and sum of the areas in y times y is 0.0065 meters cubed. Perfect. I know they're not asking for x bar, but I just want to show you guys that it works. So you divide this by this and you get 0.008 over 0.04. This is meters cubed and this is meters square, so the cube cancels out with this, and you're gonna get that this is equal to 0.2 meters, just like we said by symmetry. And then the y, 0.0065 over 0.04 meters cubed meters square is 0.1625 meters. So final answer, it shows you that this is somewhere around, if this is, okay, hold on, this is 100, yeah, so it's gonna be somewhere around here, but they drew it over here. So final answer and final answer.